For decades, we told ourselves black holes were objects located within space. The truth is far more disturbing. They are the places where space itself ceases to exist. We thought we understood the end of matter. But today, new data suggests we aren't looking at the death of stars, but the fracture line of our entire reality. Everything you thought you knew is incomplete. To understand why our previous image is collapsing, we must look at data we've only recently acquired. In 2019, the Event Horizon Telescope team achieved the impossible, the first image of a black hole M87. What we saw wasn't a solid body. It was a shadow, a hole in the geometry of the universe. Adam Rees, a Nobel Prize-winning cosmologist, has shown that the universe expands faster than our models allow, and black holes seem to play a role beyond mere gravity. This role suggests a dark connection we are only beginning to measure. In 2022, researchers observing the orbits of stars near the galactic center noticed something chilling. These stars move with a precision that defies old models. It's as if the black hole isn't just pulling them, but dictating the very fabric they inhabit. We call this frame dragging, a literal twisting of space-time. If you were close enough, the universe wouldn't just look different. The definition of straight would physically vanish. Consider a number that changes everything: the mass of Sagittarius A at the heart of our Milky Way. 4.1 million solar masses concentrated in a point that should have no volume. This isn't an object in the classical sense. It is a mathematical error made flesh. We use the word whole, but that is a dangerous simplification. Imagine a house built in 1 second, without materials, solely from the pure logic of architecture. That is how black holes affect our physics. They are the result, even when the process behind them no longer makes sense. Our foundation rests on Albert Einstein's general relativity. He taught us that mass curves space, like a bowling ball on a trampoline. But black holes are the moment the ball becomes so heavy it tears the fabric. But here is the problem most documentaries ignore. If the fabric tears, where does the ball go? We often speak of the event horizon. Think of it as a finish line where time stops. To an outside observer, an astronaut falling in would never arrive. They would freeze at the edge, fade to red, and remain there for eternity. But for the astronaut, the journey continues, straight into the abyss. Here we meet Stephen Hawking, who applied thermodynamics to these monsters. He proved that black holes sweat. They emit radiation. Hawking radiation. This means black holes are not eternal. They evaporate. And here is the shock moment. When a black hole evaporates, does the information about everything it ever devoured vanish? If you burn a book, the information survives in the ash and smoke. But a black hole seems to erase information from existence entirely. This is where quantum mechanics goes to war with relativity. Perhaps we've been looking in the wrong direction. What if a black hole isn't a three-dimensional construct at all? Physicists like Leonard Susskind have proposed a hypothesis so radical it feels like science fiction: the holographic principle. It suggests that all information about the interior of a black hole is stored on its two-dimensional surface, the event horizon. Think about that. If this is true, then the depth we assume inside is an illusion, like a hologram on a credit card that appears three-dimensional but is flat. Now the escalation. If black holes function this way, the entire universe might too. You could be a shadow of information existing at the far edge of the cosmos. You feel solid. You feel the weight of your body. But the science of black holes whispers that this solidity is a construction of your brain to process a reality that is, at its core, just data on a two-dimensional boundary. We are not actors in a space. We are the projection of information at the edge of nothingness. This creates a deep rift in science. We have two irreconcilable perspectives. On one side stands general relativity, describing a smooth ride into the singularity. On the other, quantum physics proposes the firewall paradox. Joseph Polkinski, a renowned string theorist, argued that an astronaut doesn't just glide through the horizon, but instantly incinerates in a wall of high-energy particles. Two theories, two realities, both mathematically sound. Both cannot be true. Edwin Hubble discovered the universe is growing, but he couldn't have known we would hit a wall where language fails. When we look at black holes, we see scientists arguing like theologians. Roy Kerr showed us these objects might possess a ring singularity. A gateway? A transition? We do not know. The nuance is painful. We lack a theory of quantum gravity. We stand before the black hole like primitive humans before a smartphone. We see the light, but we have no grasp of the architecture. Why is this more than a fact? Because black holes show us the universe has a limit to knowledge. There is a realm from which no message can reach us. It is nature's ultimate censorship. In the silence of this realization lies a dark beauty. Every atom in your body is information the universe has borrowed for a brief moment. But what happens when time itself ends? Inside a black hole, space and time swap roles. The path to the singularity is no longer a direction in space, but a direction in time. You can no longer escape the singularity any more than you can escape tomorrow. The end isn't out there, the end is now. Dostoevsky once wrote that man cannot find the secret of life as long as he clings only to the visible. Black holes force us to accept the invisible as the only true reality. They are the graveyards of time. We reach the decisive point. If black holes store information as a hologram, it means the universe has a memory. And this memory is physical. When you look into a black hole, you aren't looking into darkness. You are looking into the highest concentration of knowledge physically possible. It is the hard drive of the cosmos. We thought black holes were vacuum cleaners. But what if they are the engines? Recent observations suggest galaxy formation is inseparably linked to the growth of their central black holes. Without the monster at the center, we wouldn't exist. Without the darkness, there would be no light. We are children of the singularity. In the distant future, every light in the universe will go out. Only black holes will remain for trillions of years, until they too evaporate and release the last bit of information into the void. We thought black holes were part of the universe. In truth, they may be the only thing left of it. Perhaps the universe isn't designed to harbor life, but to produce black holes. And we are merely the fleeting byproduct of a process we are only beginning to glimpse. Reality isn't what we see, it is what remains when space tears.